Good morning, everyone. Hello, hello. We will be finishing quote chapter 1, which includes section 3.6 today, which will conclude the material for our first test. We will talk about a few things regarding that. Let's do it after the section completes. Let's do it after the section completes. And then, so we just got to do 3.6 part 2. Then we'll talk about the first test coming up, the review, all that jazz. And then we'll get into 2.1. I might have to end class 10 or 15 minutes early today. We'll see. I'm waiting on a text. So yes, I will be checking my phone for a text message. Sorry, I'll be rude, but hey, you can't see me, so does it really matter? Okay, so where were we? You have the due dates up here per usual. So 1.7 is due on the 5th. What I would like to call 1.8, what is really 3.6, and oddly split into two parts. They're both due on the 7th. That's probably the shortest set of questions out of all of the chapter 1 homework assigned to you. Also remember that if you complete the prereq assignment, I think I said a 90 or higher. If I'm misquoting, someone can say that in the chat, but that's usually what I do. I usually say 90. So if you get a 90 or higher on the prereq, maybe I said 80. Oh, I'm gonna have to go back and look at that recording. Either way, then you get 5 bonus points towards the first test. That's the only time that's gonna happen. There's not gonna be another case of that in the future, just so you know. This is a one and only situation. And you would have to manually add those 5 points to your grade. The My Math Lab grade that you see for your test 1 would not include those 5 points. So if you completed the prereq material homework assignment, and you originally, it says you have an 89, that means you actually have a 94. Again, I will not change that grade in My Math Lab. It's very stubborn and complicated to have to do, but you should know that you have those 5 extra points accounted for. Yeah, okay, so that being said, we can move on, not to that. As a very quick reminder on the set of instructions, which will be pretty similar to what we're about to do. So these were the set of instructions for technically any polynomial inequality, but I said for the point of our course, I'm only going to give you quadratics in the homework and on the test, at least definitely on the test. I don't remember, no, I did confirm that they're all quadratic on the homework. So it's kind of like you're solving an equation and either factoring or doing the quadratic formula, in that you want everything on one side and you want the leading term positive. So again, if we're talking about a general polynomial, then when I say x squared, I should just instead say the leading term, factor via however you need to factor, whatever method works. And then we said, you don't just set like this x minus 2 bigger than 0 and x minus 5 bigger than 0. Because of sign changes with products and quotients, when your x goes between one number and another number, this symbol right here is not entirely accurate. It's only accurate about half the time, maybe even not half the time, maybe a third of the time. It's kind of a tough number to really put down. It doesn't matter, because anyways, what we actually do is, and we just ignore the original symbol and we set it equal to 0 when we split it up. And we call these our endpoints, not our solutions. They may be part of the solution. They may not be part of the solution. Then we draw up a number line with those, and all the answers are already here already. So we draw our number line with the 2 and the 5, or whatever the endpoints are. And then we come up with test points in all 3 of the regions, or if there's only 2 regions, then in both regions, or if there's 4 regions, then in all 4 regions. And you plug the test points into any version of it as long as you didn't mess up anything along the way, so the non-factored form or the factored form. One time we showed it in a non-factored form. You're just looking for true or false statements. True means you shade that region, false means you don't. And that's how we figured out to shade the left and right ends. I said that with these problems, usually they oscillate as an on-off, so shade, don't shade kind of idea. But in the grand scheme of things, they don't all have to be that way. While I'm not going to do this example, if you wanted to do something like x squared minus 22x plus 121 is, and you could go bigger than 0, or you could go less than 0, or you could go bigger than or equal to 0, or you could go less than or equal to 0. This problem would not go true, false, true, false, true, false. it would go true, true, or false, false, depending on whether this was a greater than or less than. And that's because of the fact that when you factor this, it ends up being x minus 11 squared. And that right there, the repeated root with an even exponent, this changes that game significantly. Now, in the actual process of the problem, nothing changes. You still, 11 would be your endpoint, so you'd have to try a number to the left of it and to the right of it. And you would, again, either get true or false, depending on whether it was greater or less than, because the problem changes drastically. So then you end up either shading pretty much everything or pretty much nothing, or maybe it is completely everything or completely nothing, because the endpoint itself may or may not be included. I put stars next to this because while this should be a problem we're doing in our class, it's not in the homework set, so it means I'm not going to test on it. I don't like that, so I like to at least take 3 minutes to discuss it. But try that out. I had mentioned that you can put these things in graphing calculators to affirm some things. Remember, this is not how you'd be doing it on a test. This also is not a test problem, as I've already mentioned. But just for fun, before we move on, x squared minus 22x plus 121. And that's going to be outside the window because it's at 11. So let's make the x maximum 20. Let's do the x minimum as 0. So that just changes the width of the window. And you can see that this thing is always above the x-axis, except for at the value 11. So because this is a greater than symbol, the 11 actually would not be included. The solution of this would be negative infinity up to 11, both in parentheses and then unioned with 11 to infinity. And again, just this thing right here, whether it has the or equal or whether it changes direction, can make that answer wildly different. But again, the test point method would pick all of those details up. You would just have to be a little more careful at the end point. All right, so that aside, 3.6, part 2, technically speaking, it's still just 3.6. We did quadratics, now we're going to do rationals. Remember, what does the word rational mean? It means fraction. So rational inequalities are inequalities, which means you have the less thans or greater thans, that have fractions in them. But the fractions are going to be complicated. You're going to have x's littered top and bottom. Now, rationals, we've discussed this previously, their complications are that if you think a solution is something that makes the bottom 0, well, it actually isn't a solution because that makes an undefined answer. We have these holes in rational functions, as we'll come to talk about them, holes or asymptotes, depending on the scenario. Well, those aspects aren't that important for us here, except for the fact that if the denominator is 0, it makes it undefined. But that's all we have to worry about. We're going to be worrying about bigger, grander details. So you still move everything to one side. But then instead of just setting the whole thing equal to 0, what you'll do is one time you'll set the top equal to 0. So that'll be its own equation. That'll give you its own endpoints. And then another time, you take the bottom and you set it equal to 0, and that'll give you endpoints. So the endpoints are the values that make one of the top or bottom 0. So with the quadratics, if it made one of the factors 0. And the reason this idea is important is because the endpoints are where one of the signs is going to change typically. So if the sign changes in the top, that means the whole thing will change. Or if the sign only changes in the bottom, then that means the whole thing will change. And when I say change, I mean like go from true to false, which means you go from shading to not shading or vice versa. So with the quadratics, the idea is ultimately when you have a factored form, when you have a product, set each of the factors equal to 0. When you have quotients, the idea is set all the tops and bottoms equal to 0. So it's kind of the same idea at a core. And then step 3 is literally the same thing as before. You got to do this test point, endpoint stuff to see whether you get true or false and to see where you shade. But this right here is super, super, super important. And this is where students mess up constantly. Because we get used to, all right, if it had a greater than or equal, we put a bracket on it. If it just had a greater than, then we put a parentheses on it. Well, rationals have this one inherent issue. that we're setting the bottom equal to 0 to find endpoints, but you can't actually plug the number that makes the bottom 0 in, or else it makes the whole thing explode, so to say. It causes it to be undefined. That's what I mean by explode. So if the original problem had the greater than or equal to, and the number that makes the bottom is, say, 5, when you plug 5 into this, it's going to give you an undefined number, which means you cannot allow 5 to be plugged in. So when you put the interval notation, you would want to put a bracket around the 5 because of this part, because of the or equal. But again, just based on the idea of restrictions to rational functions, you would have to supersede that and say, no, even though it said or equals, that number cannot get a bracket, because if you plug it in, the world explodes. Now, that's only the things that come from the bottom, the bottom, the bottom, 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 bottom. Anything that came from the top is perfectly allowed to be 0, because tops being 0 doesn't make the world explode. It's bottoms being 0 that makes the world explode. So any endpoint that came from you setting the bottom equal to 0, all caps, must use a parentheses. This is number 1 classic rookie mistake that students make. So don't make that mistake. All right, what are we up to? Example 2? Yes, example 2. 2, solve, put in interval notation. We will still make the graph just like before, but I'm only asking for the interval notation. So we're going to go with x plus 3 over x minus 8 is less than or equal to 0. All right, so once again, I've given you a problem that just kind of gets down to the point. You may have to move everything to one side. You may have to combine fractions. You might say, oh, we'll just multiply both sides by the denominator to get rid of all fractions. If this was an equation, yes. This isn't an equation, and while I know we said inequalities and equations basically have the same rules, we do want to take a different route for this because of that directional and loss of sign generality issue. So we don't want to multiply both sides by x minus 8. That would actually be a really bad idea. We would in fact lose one of the endpoints if we were to do that. So don't do that. Do not try and clear the fractions here. If you have multiple fractions, it means you just got to get an LCD and squish them together. All right, so what do? We set the numerator, which means top, equal to 0, and we set the bottom equal to 0. So our side work, we set x plus 3 equal to 0, and we set x minus 8 equal to 0. Subtract 3, add 8, that gives us x equals negative 3, and x is equal to positive 8. Those are our end points. Those are our end points, not the solutions. These are where the solutions generally change from true to false or vice versa, shading to not shading or vice versa. So we can make our little number line, and we're going to put the negative 3 and the 8 up there. That is me trying to write and think and speak at the same time. That is why I read that 8 instead of 3. Those are the barriers. That's where we shade up to, but generally not crossing. Again, notice I said generally. Now for the test points, we need a number to the left of negative 3. Negative 4 sounds like my kind of test point. We need a number between negative 3 and 8. You could use negative 2, you could use 7, you could use 1, but I like using 0 whenever possible. And then I need a number to the right of 8. I'll go with 9. These blue numbers are my choice. You can make any choice you like as long as they are in that correct range of values. Then we plug them in, and we see whether we get a true or false statement in the original inequality. Now, I never had to do anything to this. I didn't have to factor it. I didn't have to move anything. I didn't have to combine anything. Your homework problems, you may have to do some of that stuff. So let's test. For the x equals negative 4, we get negative 4 plus 3 over negative 4 minus 8. And we're saying, is that less than or equal to 0? Now remember I said that you can show all of the actual arithmetic here and get your true or false answer. Or with the products, you just break these down into positives and negatives and see if you get true or falses. So this is a quotient, you can do the same idea. Negative 4 plus 3, yes, it's negative 1, but all I care about is that it's negative. So the top's a negative, then divided by negative 4 minus 8. Sure, it's negative 12, but I only care that it's negative. So is a negative divided by a negative less than 0? Well, a negative divided by a negative is a positive. And positives are not less than or equal to 0, which means we will not shade the region with the negative 4. We will not do this. This would be wrong. Okay. Now let's try out these 0. The x equals 0. We're going to have 0 plus 3 over 0 minus 8. Is that less than or equal to 0? 0 plus 3 is positive. 0 minus 8 is negative. I don't care about the actual numbers because a positive divided by a negative is a negative. And negatives are... I want to write it just a little lower. Nope. There we go. Negatives are less than 0, so it's true, which means we shade where the 0 is. I don't just shade right here. We shade from endpoint to endpoint. Now let's wait on the parentheses and the brackets. Let's see if we shade where the 9 is. So x equals 9. That would be 9 plus 3 over 9 minus 8. Is that less than or equal to 0? 9 plus 3 is 12. All I care is it's positive. 9 minus 8 is 1. All I care is that it's positive. Positive divided by a positive is a positive, and I am positive over that. Sorry for the terrible joke. Positives are not less than 0, so that's false, which means we do not shade to the right of 8. So when you don't have repeated roots, in other words, I didn't see that x equals negative 3 or x equals 8 pop up more than once, or there was no exponents involved with it. This is typically what happens as you go from region to region. It typically goes true, false, or false, true, false, true. Typically, repeated roots change that. Okay, so when we look at the original problem, here's what most students will do. They'll see the less than or equal, so they go, oh, we should bracket everything. So they bracket the negative 3, and they bracket the 8, and then my math lab tells them it's wrong. And you go, that can't be, Mr. Beckner. It has a bracket. You told me in class that the or equals give brackets. Why is my math lab lying to me? It's lying to you because you didn't pay attention to the grand details. And I've been there and I've done that. I'm not trying to be mean when I might, anytime I sound harsh, it's just me trying to get a point across. Any endpoint that came from the bottom must use a parentheses. I gave us the logic for that. Because if you were to actually, if you think this is a bracket, if you plug the 8 in here, that makes the bottom 0. You're dividing by 0, which causes the whole thing to be undefined, and boom, the world explodes. Don't allow that to happen. There we go. So because the 8 came from the bottom, even though it had a bracket, we have to take precedence over that and put a parentheses. Now the negative 3 came from the top. It is perfectly okay for tops to be 0. So that does get a bracket. So this is kind of a weird case. Weird means interesting though. Weird doesn't mean bad. The world runs on weird. So again, maybe you have to factor. Maybe there's multiple things in the top that you'll be setting equal to 0. This could have been x plus 3 times x plus 5. There could have been 3 different endpoints, which would give you 4 different regions and 4 different test points. Anything is possible. The world is our oyster. All right, one more. Again, getting to brass tacks, x plus 1 over x plus 5, bigger than or equal to 0. Well, there's no factoring involved. There's no combining of fractions involved. I don't need to move anything. It's all set. So we can go ahead and say that our endpoints are found by setting the x plus 1 equal to 0 and the x plus 5 equal to 0. Subtract 1, subtract 5, you get x equals negative 1 and x equals negative 5. These are not the solutions. These are our endpoints, our EPs, our extended plays. Sorry, music joke. Not even a joke. So make our number line. Put the endpoints up there in appropriate order. If I do this, that would be wrong. Negative 1 is not to the left of negative 5. put -5 on the left, -1 on the right. That's an easy mistake to make, so just be careful. Then come up with test points. To the left of -5, I could do -1001 if I wanted to, but you know I'm not going to. I'm going to do the closest whole number, which is -6. Between -5 and -1, I could go with -4, -3, or -2. -2 is smallest in absolute, so I'll go with that. No, these are not spaced equivalently. Please don't worry about that. And then I always like to use 0 whenever I can. So there we go. And I'm going to have to do the work down here. That's not a big deal. All right, so for the test points, let's do the x equals -6 first. So that'll be -6 plus 1 over -6 plus 5. We're asking, is that greater than or equal to 0? -6 plus 1 is a negative. -6 plus 5 is also a negative. Negative divided by negative is a positive. Positives are greater than or equal to 0, so that's true. So the -6 made a true statement, which means we shade the region with the -6. Do not just do this. Do not shade up to the -6. Going to the -5 because that was the barrier. That was the endpoint. Now you might be thinking, all right, Mr. Beckner, I know this game. I know the -2 is going to be false. I know the 0 is going to be true. So I'm just going to go ahead and shade this region and put my parentheses or brackets there. And you know what? 95% of the time, you're probably right. But you're not going to be right every time. As I've said, if there's any repeated roots, which in the grand scheme of things, you could be given a problem that there were, even though I've already spoiled I won on this test. I hate saying that. I really do, and I don't use that word very often. Because that is pre-calc level. But I'm only going to test you based on what you have in the homework, so we'll keep it to this. So please do all the testing. I do reserve the right. Let's say you got a problem wrong and it's because you made one teeny tiny boo-boo somewhere, and you go, Mr. Beckner, please look at my work on the test. And I go, okay. Well, you didn't show any of your test points. So how am I going to give you partial credit if you only showed one of the test point works? I mean, how do I know that you were allowed to skip the second and third? Now maybe a really what's the word I'm looking for? Advanced student might write that sentence, well, I know since there's no repeated roots that the true-false cycle will be maintained. You know, something like that could work, but I'd have to see something, not just, well, you know, it was in your brain. How do I know it was in your brain? All right, gotta stop ranting. Let's try -2. So that'll be -2 plus 1 over -2 plus 5. Is that greater than or equal to 0? -2 plus 1 is negative. -2 plus 5 is positive. But a negative divided by a positive is a negative. That's a weird looking equal sign. I mean, question mark. Are negatives bigger than 0? No, that's false. So we don't shade where the -2 is. Let's try out the 0. We get 0 plus 1 over 0 plus 5. Is that a positive number? Well, that's a positive divided by a positive, which is a positive, which is bigger than 0. So it's true. So we shade the region with the 0 from its endpoint to the right forever and ever. And remember, arrows on the ends if you're doing this by hand. So the original problem had the or equals, so you would just instinctively think put a bracket on both of these, but that's not quite right. One of them's right, one of them's wrong. Because the -5 came from the bottom. How do I know? Well, I set this from the bottom equal to 0, and the -5 came from me setting the bottom equal to 0. So I can't put a bracket on the -5 even though it says to. I have to say, well, even though you're telling me that, I know there's more important fish to fry, and I can't let it happen. So we parentheses the -5, but the -1 is perfectly fine with a bracket. And there would be our solution. I didn't put the last one in interval notation, did I? I did not. I graphed it. So now let's go back and do the interval notation for both of these. Let me just pull the screen back, because I did ask for interval notation and then I didn't even do it. So for A, the interval notation, we went from -3 to 8, so -3, comma 8. And then we had a bracket on the -3 and a parentheses on the 8. That was the actual solution to A, because I asked for interval notation. The graph just makes it easier to get that. If you don't make that graph, if you just went straight from the false, true, false bits, you are a little more, or maybe even a lot more likely to mess this up. You might throw the -4 or the 0 or the 9 up here instead on accident. I've definitely seen that before. For B, because of the separated regions, we will have to use a, you guessed it, union. The left region is -infinity up to -5, both with parentheses. Then we say, or it could have been, which means the union. Then we go from the -1 to +infinity with a bracket and a parentheses on the -1 and the infinity respectively. So that closes out chapter 1. Before we get into chapter 2, I'll leave that up there for another 15 seconds or so. Let's talk test details. Let's keep it in that super small font. Kidding, of course. All right, so test 1, which will cover 1.2 through 1.7, and then 3.6. This will be 20 questions. You'll have 90 minutes. And it will take place, and it will, sorry, let me say, it will be located in the quiz and test section of MyMathLab. You will have 2 full days to attempt. Calendar, is it the 7th and 8th? Yes. So it's going to be the 7th and the 8th. So it will be Wednesday, October 7th, through Thursday, October 8th. So it's due by 11:59 p.m. 10/8. There will be a review assignment located in the homework section, the section you've spent most of your time. That will be comparable to the test. While this will not hurt or help your grade, you should complete it anyways. Why? Because it's a review that's comparable to the test. The review problems will be similar to homework problems. Now, I'm not saying I'm going to give you a whole bunch of problems. The review will be 20 questions. The test will be 20 questions. So there shouldn't be any test problems that are like 5 times as difficult than questions that were on the review. The difficulty of the review questions should be on par with the difficulty of the test questions. Also, I generally don't change conceptual questions. So what does that mean? It means that if I put a fraction equation on the review, you're probably going to see a fraction equation on the test. What it also says is if I don't put a, I'm not saying this isn't going to happen. I'm just trying to say an example. If I didn't put a rational inequality on the review, then you wouldn't expect a rational inequality on the test. That's what I'm getting at. Again, I'm not saying there is or is not one of those on the review or the test. I'm just setting an example, saying an example. So do the review. It's going to be a really good idea. This will be available later than 5 p.m. tomorrow. I will try to get this done today. I cannot promise. I've got 10 billion things on my plate. Some weeks are just busier than others, and this is a busy week. So I think I've got this pretty clear cut and oh, there is one more thing I got to say with the test. So the test is in my math lab. They'll just be marking things right or wrong. And remember that you must submit work. This will be in Canvas. So, you know, like how in Canvas we had the couple of review things. I don't really have a lot available in Canvas. It's going to be in that page, on that page. So there'll just be a section that says submit your work here. You can't miss it. You must submit within 15 minutes of finishing the test. You can, if you have access to a scanner, you can certainly scan the pages that you did your work on and upload them that way. Or if you have a cell phone, you can take pictures of them and upload them that way. If you have another idea besides those two things, you might want to run it by me first to make sure that I've got the file format acceptable. But I mean, I figure most people at least know somebody with a cell phone. So hopefully, if you don't have one, hopefully you can be in the vicinity of someone that will not be helping you for your test. Now, your test is your own work. I reserve the right with any question that you get right to flip to your work. And if I see no work, I could take away all your points. Now, I'm not saying that's what I'm going to do for every problem. I'm talking about big, complicated problems where there's 10, 15 different steps. Like, let's say problem B right here. This was a test question. If this was a test question and then I see the interval notation as your answer and I go, all right, Bob, well, let's see what you did for your work, and I see no work, I'm going to go, nope, you're not going to get any points for that. And then I'll take your 5 points away from you. So please show your work. It's important. Again, I'm not trying to do something like that on simple problems. If the problem was as easy as x plus 3 equals 5, solve it. Oh, subtract 3 on both sides. Most of you probably don't need to show that work. So that's not a question that I would go back and take your 5 points from in that instance. It's not something I'm trying to do. I really don't want to have to do that. But you need to understand that this weird COVID teaching online thing, taking the test in my math lab, it is just a substitute for the pencil paper aspect. So I'm much more interested in the work than just the answer itself as a math teacher. Make sure that your name is on the work. It should be submitted under, under your section of Canvas. Everybody's got a little section when I'm looking at my Canvas. But anyways, that aside, just write your name somewhere on your piece of paper. This test, you don't have to record yourself. There's not going to be a camera. I might do that for one of the tests. More than likely, it would be the final. But for this one, I want to avoid that. I think that is a barrier of entry, and I'm not a big fan of barriers of entry. No, do not email me your work. Absolutely do not email me your work. You must submit it in Canvas. If you email it, it doesn't count. I never saw it because I need all of this in one central location. I don't want to have to open up 40 different emails. It would complicate my life. So I'm trying to not complicate your lives as much as possible. Hopefully you'll understand that and pay me the same favor. All right, so if you have any more questions, you can shoot that message in the chat, or you can email me, but this will be the test format for at least the first 3 tests. If I need to change anything, I will, but let's go with this for now. I think this will work. Okay. What do we have for time? Oh, wow, it's only 11:35. Okay, 2.1, and let's not show everything all at once. Zoom in. And the title of that section, by the way, which I don't know why I didn't type that up, unusual for me, it's something like functions. Basics of functions and their graphs. So we are going to mostly be dealing with functions for the rest of this course. Now I say mostly because every now and then something that's not a function will pop up randomly. But when we talk about doing any kind of normal graph, we're going to be dealing with functions. When we talk about analyzing, we're going to be talking about functions. And the difference between a function and what we've been dealing with so far is really minimal. We just weren't calling them functions. We weren't talking about a lot of their details except for, well, this one we did mention a couple of times, especially with the rational function with those fractions. And we were just talking about this, what, 10 or 15 minutes ago, how you can't divide by 0. So we have values that you're not allowed to use. Well, values you're not allowed to use are outside the domain. That's what that means. So the domain is just a fancy name for the list or set of x values that work for the function that you can plug in and it spits out a number. Doesn't have to be a pretty number, it just has to be a number. So an x value that you plug in and it spits out undefined would not be in the domain. But an x value that makes the function spit out 5 or 7 or 12 or whatever, then that would be in the domain. Even if it spits out 3.925314309 blah, 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 that's still a number, which means the x value you plugged in to get that would be in the domain. Domain, x values, inputs, all of those words are associated with each other. Inputs are generally your x's. Domain is talking about your inputs, which again are generally your x's. The range is just the list or set of the other things, the outputs, the things that come out of it, which we generally call the y values. So domain, input, x value, range, output, y value. In, x, out, y. Now, that says for a relation or function, we can talk about domain and range for things that aren't functions. We can. But again, generally, most things we see are going to be functions. And you will be getting a couple of things that aren't functions in this section, of course, so we can kind of tell the difference between them. All right. Well, how can we tell if something is a function? As I've said, everything can be an equation. Everything that we've dealt with that had an equal sign was an equation, which is also known as a relation. You're generally not going to hear me call those things relations, though. This word is just really not used a lot. This word, when something is a function, then we do throw that word around because it means there's some specific things going on with it. There's things we can do that otherwise we couldn't, kind of that idea. So a relation, in other words, an equation. When we say a relation, we just mean an equation like y equals 3x plus 5. That would be a relation, but it is also a function for reasons. Or if I said y equals x squared minus 7, that would be a relation, which is also a function. If I had something like x squared plus y squared equals 9, that is a relation, but it's not a function, and we'll get into why that is in a bit. So a relation is a function. So the thing we're looking at, the equation we're looking at, is a function if each input has only one unique output. If you see any repeated inputs and the outputs are not the same, it is not a function. This second sentence is just clarifying the first one. Something is a function if each input, each x value that you could come up with, that you can throw into it, only leads to one output. That's what we mean by has only one unique output. So in other words, if I think about the number 3 as my x value, x equals 3. If I plug that into the function, and the first time I plug it in, the answer is 10. So when I plug in x equals 3, I get y equals 10. What if I decide to plug in 3 again? Well, if it's a function, that means the answer will be 10. And then if I plug 3 in again, if it's a function, that means the answer will be 10. And you might be saying, well, that just makes sense. Every time you plug in a number, you should get the same output. Otherwise, that's insanity, doing the same thing leading to different results, right? Well, in math, that insanity can happen, as we will see. There are times when there's more than one output from a single input. and then it's not a function. And we've already kind of gone over that idea with that plus or minus square root idea. So each input can only have one unique output. So I'm saying if you put 3 in to your function, this is just typical notation that we'll never use again, and it spits out a 10. So if I put 3 in again, I'm just going to write f this time, then it should spit out a 10. Then it's still a function. If I put 3 in again, then it should spit out 10. This does describe a function. But, so these first 3 cases, if these are the only things I'm looking at, it's a function. Now you can plug in other x values as well. I could be plugging in 5 and 7 and 9, and that won't matter. But let's say I go in and I put 3 into this machine, whatever it is, this algorithm, this equation, and I put it in, I think it's a function, but when I put it in, all of a sudden I get negative 100. Well, now, with all of these accounted for, this is not a function, because we have the same input leading to different outputs. Something's a function if each input only has one unique output. So this has a different output, so that's no longer one unique output. So again, if you just use the black ink, it's a function. Once you include that fourth one on the bottom, it is no longer a function. So that second sentence I gave you, this is the quick way to just learn how to do this functionally. Ha ha ha. If you see any repeated inputs and the outputs are not the same, it's not a function. So this is your yellow flag. This is your yellow flag. If you see any repeated inputs, there's a yellow flag on the field. A yellow flag doesn't mean anything's bad, it just means we got to keep our eyes peeled. And I know that sports analogy isn't perfect, but just go with it. I'm going for yellow as like a warning. The outputs are not the same. So, okay, I see repeated inputs, repeated inputs, repeated inputs. But then I see 10, 10, 10. Those are the same, so that's okay. But then all of a sudden when I see this one, and that's different, it's no longer okay. That's why I said, if you're only considering the first 3, if this is the problem, then it's a function. But if I give you another example and the fourth one's up there, it just takes way too long to copy paste this and try and rewrite everything. That's why I'm saying just imagine it's 2 different examples. Now it's not a function because repeated input. So when you're trying to tell if something's a function, don't even look at any of this at first, just look for repeated inputs and you go, oh, definitely repeated inputs. So once you see the repeated inputs, that's when you start eyeballing the answers. 3 led to 10, okay. 3 led to 10, okay. 3 led to 10, okay. 3 led to negative 100, nope, not a function. Functions don't have to be mathematical in nature. A blender is a function. You take an orange, you put it in your blender, you hit the on switch, hopefully it was plugged in, and then you get orange juice out of it. Your input would be an orange, your output would be orange juice. So every time you put an orange into the blender, you expect to get orange juice out of it. That would be a functioning blender. But maybe one morning you wake up and your brother just discovered a black hole in the bottom of your blender. So you put your orange in and all of a sudden it spits out grape juice because on the other end, you've got some weirdo taking your orange, swapping it for grapes. That's no longer a functioning blender because you now have put the same thing in and got a different answer. A wood chipper is a function. An oven is a function. You yourselves as human beings are functions if you learn and do things properly. All right, so those are the answers. Don't look at that yet. Example 1, identify the domain, the range, and if it's a function. So there's 3 answers for these. You're going to have 1 answer for the domain, which will be us listing all of the unique inputs, aka x values. Then you'll have 1 answer for the range, which will be us listing all of the y values, or the outputs. And then we'll say whether it's a function or not. Now this, I've listed them as a set of coordinate pairs. So the curly bracket says this is a set, and then each pair of parentheses is a coordinate pair. So that's like having the 3 is the x and the 5 is the y, the 1 is the x and the negative 9 is the y, et cetera, et cetera, et cetera. I could have also given this to you as a table of values. I'm not going to do it for B, but I will for A. X, Y. So 3, 5 would be the first one. 1, -9 is the second one. -2, -9 is the third. 3, 5 is the fourth. This is literally the same problem as the A typed up. I could also draw this up as a graph of just 4 coordinate pairs disconnected. They're just little blips, something like that. I'm not saying that's where they are, I'm just giving you an idea. Okay, so for the domain, we are just listing the x values. Now, any repeated x values, we only need to list once. When you're listing domain and range, you only need to list each value once. Now, most often you're going to be doing these in interval notation, but that's only for what we call continuous functions. This is a non-continuous function. This is just a list of discrete points. Discrete meaning discontinuous. So one over here, then one over here, et cetera, et cetera. So we're just going to list these as a set of numbers, and because of cool features, we generally don't even need to have them in any particular order. So what are the x values? I see a 3, I see a 1, I see a -2, and I see a 3. But the 3 is repeated, so I don't need to list that in the domain twice, just once. So 3, 1, and -2. Now, just doing it this way, pencil and paper, is perfectly fine. My math lab might ask you to do it with curly brackets around it, so pay attention to their instructions. Also remember, this is chapter 2. This will not be on the first test. There's your domain. Your range would be the list or set of the y values. And again, whether they're in curly brackets or not just depends on the software. If this is a paper pencil test, I wouldn't even care about that because it's not like it's exact interval notation. They're non-intervals. All right, for the range, that's the list of the y values. We got a 5, we got a -9, a -9, and a 5. Well, 2 of those are repeated, so list each one only once. So the 5 and the -9. If you wanted to write the -9 before the 5, go for it. With the blue one, with the domain, you could go -2, 1, 3. If you want to put them in ascending order, that's fine. Final question, is it a function? So let us, and we're only looking at A, not B, A. The idea is if you see any repeated inputs, that's the yellow flag. Do we see any repeated inputs? Well, here's a 3, and here's a 3. That's a repeated input. The 1 and the -2 are their own thing. They will not even cause issues. Because the 1 isn't listed twice and the -2 isn't listed twice, while I'm thinking about is it a function, yes or no, these points have nothing to do with anything. It's just the first and the last one for this problem. So if you see any repeated inputs and the outputs are not the same, it's not a function. Well, 3 led to 5, 3 led to 5. So this is exactly what you would expect under normal sane conditions. We keep doing the same thing, we plug in 3, and we get the same answer. So yes, it is a function. I don't know why I wrote the answer there. Let's put it with the rest of A. Yes, it's a function. And I wanted to just show you here, the typed version, I did not put the curly brackets. So like I said, paper pencil, I don't really care about that. This is not a typical homework or test question though. Once again, when we talk about domains and ranges, we're typically doing things as interval notations. This is an atypical problem. We're just kind of putting our big toe into the waters to get a feel for everything. All right, so now let's try B. Domain. Well, the first 3 points are literally the same. So the domain, well, and the fourth one has a 3, so 3, 1, -2, and 3. So it's the same thing. Keep the color the same. 3, 1, -2. Or no curly brackets, whatever works in my math lab. The range, well, that's the different y values. We have a 5, we have -9, -9's repeated, and then we have 100. Oh, so there's 3 values this time. So it's going to be 5, -9, and 100. And And is it a function or not? So remember, that warning sign is if you see any repeated inputs. Well, I see a repeated input. Here's us plugging in a 3, and here's us plugging in a 3. So there is a yellow flag on the field. There's a warning. Maybe it's not a function. If I did not include this fourth point, this is automatically a function because there isn't even any repeated inputs. So these 3 points form a function. But the fourth point is there, so let's see what happens. All right. So one time we plug in a 3 and we get a 5. So that says to be a function, every time you plug in a 3, you should get a 5, or you're insane in terms of a function. But later we plug in a 3 and we get 100. So this is us plugging an orange in one time and getting orange juice. Then later we plug an orange in and we get banana juice. That is not a function. And the issue is the first and last point because they have the same input but different outputs. No, not a function. So here's what some students will do wrong. They'll look at the first one and they'll say, no, this is wrong, and they'll say it's not a function because of this -9 is repeated, but the input is a 1 here and a -2 here. You've missed the point entirely. We don't care about repeated answers. We care about repeated inputs not having repeated answers. This is not what you should be looking at first. Don't look at the y values or the second values at all until you found out if there's even repeated inputs. So these -9s repeating and having different inputs, that has nothing to do with the function. It has something to do with something that we'll talk about in chapter 2. I'll even spoil the name of it. It's known as inverse functions, but it's because inverse means you're flip-flopping the entire idea. So the -9 all of a sudden becomes the critical issue, but let's not jump the gun. All right, so this is not the only way we'll be asked domains and ranges. We'll be given graphs, and you're asked the domains and the ranges, and whether they're functions or not. We'll be given equations, and you'll be asked whether they're functions or not in their domains, but not their ranges. That's actually a little out of our pay grade for some functions, so we keep it out of pre-calc 1 at this level. But it's the only thing we skip. So we'll be looking at equations, graphs, and sets of data, and finding domains, ranges, and whether they're functions or not, with exception of equations and ranges. That's the one we'd skip. So what about when we have the functions as equations? Like I write out y equals 3x plus 5, or y equals x squared minus 9, or y equals the square root of 2x plus 3, or 5x minus the square root of y equals 7, or x squared plus y squared equals 25. How do you tell whether they are functions or not? Well, there's a lot to that in theory, but we're going to get a shortcut on that. The idea is supposed to be that if you can take the equation and solve it for y, and there's no super weird oddball thing going on, which is generally a plus or minus, then it's a function. And that plus or minus is going to be the one issue I will show you ultimately. But I'm going to give you a super secret, top secret hint that in our class, notice I said in our class, this is not true in the world because in the world there's much crazier functions. But in our class, if I give you an equation and I ask you if it's a function or not, the answer is yes, unless you see y. Now, it doesn't say anything raised to an even exponent. It says y, not x, y raised to an even exponent, then it's not a function. We will do some examples. We'll give our yeses and nos, and then I'll explain the basic reasoning of this without any kind of formal proof. And again, real world, there's a lot of other equations that aren't functions that wouldn't follow this rule, but I guarantee you, homework and test, this is the rule that you'll need. So, example, oops, select 2, function, question mark. I love simple instructions. Is it a function? And For A, we're going to go with 3x plus 5y equals 9. So there is an equation, and I'm asking if it's a function. Do you see a y raised to an even exponent? Well, here's your y, and the exponent is not written, which means that it's really a 1. So no, you do not see a y raised to an even exponent, which means it's as easy as this. Yes, it's a function. That's it. That's the whole problem. Now, in terms of showing your work on something like this, the only thing you can really do is write a sentence, I don't see a y raised to an even exponent. Or you could say the more detailed thing and say that, yes, I could solve this for y, and there's no plus or minus in there. That's the thing I mentioned that we'll talk about. So that's the only work you could really have for this. But these yes or no questions, it's usually not something you give partial credit to. So not a major deal. B, y equals 4x squared plus 2x minus 7. That got a little sloppy. Sorry for that. I'm not hitting undo, am I? X squared plus 2x minus 7. And a lot of people will say, oh, well, I see an x squared, so no. And they're wrong. Yes, there's an x squared. But I don't care about x's being squared. We care about y's being squared, or to the 4th power to the 6th power. The y here has a 1 as an exponent. In fact, it's solved, and there's no plus or minus nonsense. That is the idea that, yes, it's a function. You can solve for y, it's a function, as long as it's a no-nonsense solving for y. For C, this has got to be, yes, it is, x squared plus y squared equals 25. Look at this. You got a y. You got an even exponent. If you see a y raised to an even exponent, it's not a function. Yeah, it's a little bit memorization-y. Like I said, I will show you the reasoning as to why that is, and I will do that in about 15 seconds. All right, so here's the logic. Take C, solve it. So we had our x squared plus y squared equals 25. Let's move the x squared over to the other side by subtracting it. I don't want to put it under the 25 because they're not like terms. And that gives us y squared equals 25 minus x squared, or you could write negative x squared plus 25. That would be the same thing. Now, I don't care what this is. It's just something. If you have something squared equal to something else, if you wanted to solve for this thing, you might say, take the square root of both sides. You might say this, oops, wrong color. This is what you might say. And you're close, but you're off by just a teeny bit. So you had your y squared, you had your 25 minus x squared. This is the right idea, but not perfect application. Because when you have something squared equal to a number, it wasn't just take the square root of both sides, it was take the plus or minus square root of both sides. How many times have I said that that issue isn't going away? So when you do this, here's what you get. On the left side, you get y equals. Then plus or minus. No, you cannot do this. This would be wrong. You cannot say 5 minus x. You cannot take these square roots separately because of the plus or minus factor going on. I'm sorry, not because of the plus or minus, because there was a plus or minus here. I phrased that a little poorly. So this is plus or minus square root of 25 minus x squared. That's all you can do with this. But because there's a plus or minus here, that says that this is not a function. But why exactly is that? Try plugging in x equals 0 and see what it is, what happens. what it is, and what it ought to be. Now remember, the idea of something being a function is if you plug in a single x value, you get a single y value. Spoilers, it's not happening here. So we go y equals plus or minus the square root of 25 minus 0 squared. Well, 0 squared is 0, so that's plus or minus the square root of 25 minus 0. So y equals plus or minus the square root of 25. Square root of 25 is 5. So we get y equals plus or minus 5. This is 2 outputs from 1 input. Oops, input is what it looked like I just wrote. Input. Ignore that typing stuff below there. Please don't make that go away. And it does. That's all right. From 1 input. That is why plus or minuses are bad for functions. They can't be functions if there's a plus or minus in there, because by definition, it means if you plug in a single x value, you're gonna get 2 y values. So one time you plug x equals 0 and you get 5, one time you plug x equals 0 and you get negative 5. That's not a function, that's quote insane. Does that mean that this x squared plus y squared is 25 is garbage? Absolutely not. It's still an equation. It's a perfectly valid equation. You can still graph it. It's a very, very, very particular graph. It's a very, in my opinion, cool graph, but you know, I'm a math geek, so my sense of cool is completely off. But this x squared plus y squared equals 25 is perfectly sound. It's just not a function. Does that mean it's terrible? No, it just means that it doesn't have certain features. So that is why the idea is, for something to be a function, you should be able to solve it for y, and there's no plus or minus in it. That's the basic pre-calc 1 concept. Again, there's other types of equations out there that aren't functions for other reasons besides that, but they all have kind of a similar idea. It might just not be a plus or minus. It might be something else. You can do weird things with absolute values and make them not functions sometimes, but we're not going to get into that. Okay, so how do we tell if an equation is a function? Look for y raised to an even exponent. That's the no, that's the red flag. That's all it is. If you want to go through and do the more methodical way, A and B you could have solved for y, B you literally had to do nothing. C, when you try to solve for y, you have to use a plus or minus, assuming you do everything correct. If you forget the plus or minus, you're just going to get y equals square root, blah, 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 and you're going to think it's a function. But you messed up that thing that so many people mess up. Don't mess it up. All right. The domain and range of equations. I already mentioned we won't do the range of equations in here. A little above our pay grade. The domain, we're going to wait a few sections to come back and do. So we're going to go ahead and go to the graphs part now. So again, we will circle back to the domain of equations later, but not yet. So now functions as graph. Let's talk about their domain. Let's talk about their range and whether or not they're a function. In order for a graph to be a function, the graph must pass what we call the vertical line test. And I know at least half of y'all have heard of this before. If not, then you skipped algebra 2 and probably shouldn't be in pre-calc. And I know I've said these things before, but this new system terrifies me where you just tell people where you think you should be in, and then they place you there. Scary. Hopefully people aren't lying. Hey, yeah, put me in calculus. Well, what's the best math class you had? Algebra 1? Maybe you shouldn't be in calculus. No, put me in there anyways, boss. Oh, I hope no one's actually doing that. Okay. The graph must pass the vertical line test. This is another, you're not going to get partial credit for this, really. It's all or nothing. You get your 5 points or you get no points. I can give like a point or two for partial credit if on your work you showed you trying to do the vertical line test, but almost no one does if they get the answer wrong. So like I said, really it's all or nothing. The vertical line test is that you can draw a vertical line anywhere and only touch, wow, that misspelling has been there over a year. You can only touch the graph at most once. So let's say here's your graph. The graph is the curve. The axes are not the graph. That's just what we use to make the graph. So I'm saying, and we usually do these with dotted lines. Here's a vertical line that touches the graph once. Here's a vertical line that touches the graph once. Here's a vertical line that touches the graph once. You're supposed to be able to do this. In theory, literally everywhere, millions and millions of times, but each time you do it, it only touches the graph once. And that one would be a particular function. That particular example would be a function. Whereas, oops. If you had a graph like this, sure, I can draw vertical lines over here and it doesn't touch at all. Doesn't touch at all. I can do one right here and it touches once. And all those say that it is a function. But if you do a vertical line anywhere on this right side, you touch it once, twice, and that instantly says no, not a function. It can work everywhere except for one vertical line. If it fails a single vertical line, it fails for the whole thing and it's not a function. Now, you don't literally have to draw up a million vertical lines. Usually 2 or 3 are good enough to make a conclusion. You just have to make sure that you're accounting for all oddities. So any vertical line drawn can only touch the graph at most once. Twice means not a function. And it's these simple heads or tails things that people mess up on tests, and you don't want to lose 5 points over such a ridiculously simple question. But so many students do. So let's try this out. Let's do several examples. I mean, I basically gave you 2 free examples already. Example 3, why did the font get so small all of a sudden? Is it a function? Question mark. Let's take what I drew in my second little example earlier, but instead of having it be sideways, let's point it straight up. I mean, not literally straight up. Let's also just put that in a better spot. There we go. This is a standard parabola, y equals x squared. We will be studying these extensively in this chapter, and they will never go away. So the idea is, all right, I can draw a vertical line here, and it touches the graph once. I can draw a vertical line here, touches the graph once. I can draw a vertical line here, touches the graph once. I can do this anywhere. Now, don't be slick and say, oh, if I draw it right here, it actually touches this part of the arrow of the graph and then this part of the arrow. That's not how things work. The arrow doesn't count. So yes, that is a function. For B, I actually swapped A and B for some reason, not that it matters. Just on my paper notes. Let's put a single number. Actually, I'll do it on all the axes. 5, 5, -5, -5. So this is a circle, and the axes do continue on forever and ever in each direction, but the circle is just there. So this is a circle with a radius of 5 centered at the origin. We will learn these equations eventually, but I'm gonna actually show you something shortly. All right, so if I draw a vertical line over here to the left of where that -5 is, doesn't touch it at all. That's okay. If they all did this, it would be a function, believe it or not. I could do it to the right of the +5 as well, but I don't want to do this too many times. If I draw it right on the cusp of the circle so that it just touches that +5 once, oh, okay, yeah, this is a function, right? No, you have to imagine drawing this vertical line in all the different sections. You draw it anywhere in the middle, once, twice, boom, not a function. So I want to point out something. This is the equation of a circle with a radius of 5. Again, this is the equation of a circle with radius 5 centered at the origin. And it's not a function because it fails the vertical line test. Let's scroll back up. Back to C, x squared plus y squared equals 25. This is the equation, as we'll learn, of a circle with a radius of 5 centered at the origin. This equation right here is literally the same equation as what would be graphed to get to B. When we looked at it as an equation, we said, no, it's not a function. Sorry, I scrolled too far. We said, no, it's not a function. And that's because of the whole plus or minus aspect if you try to solve for y. So here's what the vertical line test is. It's kind of the same association with this plus or minus. Because right here, let's say, here's our x equals 0. Right here is x equals 0. So if you plug in x equals 0, you could get a y value of positive 5, or you could get a y value of negative 5. So that's a single input leading to two outputs. So if you have any 2 points aligned vertically, it's not a function because that's one input leading to two outputs. It's as simple of an idea as that. C. Let's scroll down just a little more. I hate when my mouse does that. Y. This one's going to be a little weirder. I'm going to put a negative 4 right here. I'm going to put a negative 2 about here. Let's put a positive 6 about here. Do the graph in blue. I'm going to do a solid circle right here, and then I'm going to draw a horizontal line just going to the right of that. And then I'm going to do an open, not shaded circle here at that point, and then I'm going to do a downward angled line facing down and left from there. So, is this a function, yes or no? Well, if I draw a dotted line right here, it touches once. Do it here, it touches once. If I do it way over here, sorry, that's a little slanted. Just pretend that's vertical, it would only touch once. If I do it here, it would be once. Anywhere, pretty much, it's only going to be once. Now, let me fix that. Once. But if I do it right here, what happens? If I do a dotted line, vertical line, right here, now it looks like it touches twice, doesn't it? It looks like it touches here, and it looks like it touches here. I mentioned something in passing, what, a week ago, maybe? A week or a class ago, one or the other. That parentheses and brackets are associated with open and closed circles. Parentheses are open circles, brackets are closed circles, which means without the or equals, it's an open circle. With the or equals, it's a closed circle. So it looks, a lot of people think that this touches twice, but in fact, this is an open point and not included. That's an open point that's not included. So in fact, this vertical line only touches the graph once. It only touches it on the top shaded one, not the open bottom one. So yes, it is a function. And that is time. So when we pick up next time, we'll talk about listing the domain and ranges for functions. We'll come back and do the domain and ranges of these three examples. Yeah, so we have not finished 2.1. It's not due in a week, but we did finish chapter 1. We finished including 3.6. So please remember that 3.6 homework is due in a week. That first test is coming up a week from today, but you'll have a 2-day window to do it. You'll have an hour and a half to complete it. You will have to show your work. Remember to submit it in Canvas. I will put these instructions up on the board for the next 2 classes. I absolutely will not accept late work or late tests unless you have a doctor's note, something like that. All right, so have a good one. Take care. We'll see you next class. And this will be up in a couple hours.